Hi students, today I'm going to start a lecture series on 10th mathematics, that is SSC. First we are going to start a chapter called trigonometry, in which we'll see about the right angle triangle, trigonometry chapter. In this we are going to see first naming the sides in a right triangle. Okay, right triangle. First of all, I'll tell you what is a right triangle called. A triangle, we know that it basically consists of three sides, and a right triangle is the one in which we have one of the angle is going to be 90 degrees. A, B, C we take, and one of the angle B is 90 degrees. We know that total sum of the angles in a triangle is going to be 180 degrees. So out of this, if any one of the angle is 90 degrees, such triangle is called right triangle, right angle triangle. Okay. Now where this applicable, why we are studying basically it is, for example, we are watching a wall or a building, we have a wall in front of us or an electric pole in front of us, we're watching with an angle, we are going to watch, we need to raise your head and we need to raise your eyes to watch the top of the wall, tops of the wall. So then what, with which angle we watch the top of the wall, that is angle theta. Okay, and the BC here it is given, that is the height of the wall. So in this triangle we are going to have basically three sides. One is AC, BC and AB, and we have the names, that is what the title of this topic which we are going to see now in the trigonometric chapter, naming the sides. Naming the sides in a right triangle. Right triangle means in which we have one of the angle is going to be 90 degrees. So first we'll see the naming of the sides. In this we have AC. Okay, this AC is called here it as hypotenuse. AC is called as hypotenuse, and other two sides which we have here, AB is called as adjacent side of the angle A. AB, this is AB which I am marking with the blue color, that is adjacent side of the angle A. It's theta here. And we have another side, that is BC, which is nothing but opposite side of the angle A. BC is opposite side of the angle A. Opposite side of angle A. Right. So these are the three sides in a right triangle we have. Another important thing here which you have to remember is, whenever we take for example angle BAC, suppose we are taking angle BAC, it is nothing but we can take it as angle A itself. We can consider angle BAC, whichever the alphabet we have at the center, that is the angle itself, angle A, and here it is going to be angle theta. Okay, so this you have to remember. For example, if you are writing angle BCA, which is nothing but angle C, we can write it as angle C. Right, these are the about three sides of a right triangle. Now we can have the right angle triangle which I have drawn earlier, like Another way also we can draw the right angle, that is, here we have the angle theta and we can give the names as PQR, or even we can have another way of drawing the right angle like this. And here we have the 90 degrees, and in this PQR we have angle P is 90 degrees. And here if you take X, Y, Z, and here we have 90 degrees is angle Z. So these different ways we can represent the angles 90 degrees. And hypotenuse is going to be the longest side of all the three sides, and adjacent side, then we have another is opposite side. Okay, so this about namings of the sides in a right triangle. Now another topic which we have here is trigonometric ratios. Trigonometric ratios, in which we define the ratios in a right angle triangle. The ratios which here we have with respect to opposite side, adjacent side and hypotenuse, we are going to define the trigonometric ratios. This is very important, that is trigonometric ratios. I am very slowly explaining because it's a starting chapter and you have to understand starting topics are very important basics it is, so I'm explaining little bit slow. So here we have different angles called sine of A, or we can write it as sine A, or we define it as sine of A. By definition of this, it is nothing but length of the side opposite to the angle A. For example, here I will draw the triangle like this. So if you take this as angle theta, or angle A also, here we given that theta can be 60 degrees, 30 degrees, 45 degrees, whatever it is. Side of length opposite to the angle A, that is opposite means this BC. So length of this BC, it can be some value, it can be 5 centimeters, whatever it is going to be some value 5 centimeters, 4 centimeters. So length of the opposite side to the angle A divided by length of hypotenuse. Length of hypotenuse. What is hypotenuse here? AC is called as the hypotenuse. Length of hypotenuse. Right. So this we can write as an equation. Opposite side is nothing but BC and hypotenuse is going to be AC. So this is defined as sine A, or sine theta also we can write, sine A also we can write. Now coming to the another ratio, here we have cosine of angle A, cosine of angle A, or we can write it as cos A. For this definition, we can write it as cos A is equal to length of the side adjacent to angle A. Length of the side adjacent to angle A whole divided by again length of hypotenuse. Length of hypotenuse. The spelling you have to be careful. HYPOTENUSE. Okay, that is hypotenuse, length of the hypotenuse. So that is going to be adjacent side here, when we consider, which I am darkening here, that is AB. AB is the adjacent side divided by length of the hypotenuse, that is going to be AC. So here cos A, cosine of A, it is nothing but AB by AC. Another one, here we have ratio, that is tangent of angle A, or it is called as tan A. Here it is nothing but tan A is defined as length of the side opposite to angle A, that is BC, divided by length of the side adjacent to angle A, that is AB. So BC divided by AB, BC divided by AB. BC is here length of the side opposite to the angle A, and AB is length of the side adjacent to A. So we have that is BC by AB. This is defined as tan A. So you have to remember sin A, cos A, tan A ratios. And here we have even reciprocal of this sin A, cos A, tan A, that is 1 by sin A, 1 by sin A, it is nothing but cosecant A, and 1 by cos A, it is nothing but secant A, and 1 by tan A, it is nothing but cot A. Okay, this is very important, you have to memorize this. 1 by sin A is cosecant A, 1 by cos A is secant A, 1 by tan A is cot A. These are the some of the relations which you have to remember. Thank you very much. I'll be posting the videos every day. Thank you for watching. Please subscribe and share. Thank you. Hi students, this is a lecture number 2 in chapter trigonometric in the 10th class. We are going to solve an example problem here. That is, they have given a right angle triangle with this hypotenuse, and this is A, B, C. Here we have the angle C, and we have the right angle triangle is B, 90 degrees. And here we can find the ratios related to angle A are ratios related to angle C. Both are different. Okay, for example, if they ask to find sin C, then the opposite side, as we have seen in the previous lecture, opposite side to the angle C is AB, and the same way if you see the opposite side to angle A, that is BC. Okay, so you should be careful which angle they are asking. For example, if they ask sin C, that is length of the opposite side to angle C is nothing but AB, and divided by our hypotenuse AC. Suppose in the example problem they mention the lengths in centimeters, that is length of BC is 5 centimeters, length of AC is 13 centimeters. Then if they ask find sin C, it is going to be, and suppose this they have given 7 centimeters, AB also given, AC is also given, BC lengths all are given, and they ask sin C, so opposite side, length of the opposite side, it is 7 centimeters divided by AC is nothing but 13 centimeters, length of AC. And since it's a ratio, centimeters will get cancelled, and we get the sin C is going to be 7 by 13. Okay, suppose if they ask to find what is sin A, so now when we watch from angle A, the opposite side to angle A is nothing but BC. So the length of BC divided by hypotenuse. Hypotenuse is going to be same in angle C case or angle A. That is going to be AC. So the length of BC it is 5 centimeters, and divided by the length of AC it is going to be 13 centimeters. Centimeters, numerator and denominator will get cancelled, and we get it as 5 by 13. That is going to be sin A. Similarly, if they ask what is cos C, cos C, here whenever we want to find the cos of an angle, we have to find the length of the adjacent side, adjacent to angle C, it is nothing BC. length of the adjacent side, it is BC, divided by the hypotenuse, that is AC. So length of BC is nothing but 5 centimeters, and length of the hypotenuse, it is going to be 13 centimeters. Again centimeters will get cancelled, since it's a ratio, it is going to be constant. 5 by 13 is going to be cos C. Suppose we want to find what is cos A. Cos A we want to find, adjacent to angle A is nothing but a AB. This is the adjacent side to angle A. So length of AB is going to be 7 centimeters, and the length of the hypotenuse is going to be 13 centimeters. So we get it as cos A is going to be, we have AB 7 centimeters divided by 13 centimeters, we get it as 7 by 13. This is going to be cos A. Okay, so like this we can find the ratios related to cos A, cos C, or sin A, sin C. And another important relation here we get with respect to the ratios is, we have seen already that, again I am just briefing here. We know that sin A is 1 by cosecant A, and cos, we have cos A is nothing but 1 by secant A. Vice versa we can write. And another we have tan A is going to be 1 by cot A. Remember these ratios. And tan A is nothing but, we have length of opposite side to the angle for which we want to find the tangent, divided by length of adjacent side for which we want to find the tan of the angle. So we know, we have seen already that sin A is nothing but length of opposite side and divided by hypotenuse, length of hypotenuse, HYP we can, hypotenuse. Whereas cos A is length of adjacent side to the angle A divided by length of hypotenuse. Okay, suppose if you take the ratio of this sin A by cos A, the length of hypotenuse will get cancelled, and we get, it is nothing but sin A divided by cos A if you take. So lengths of hypotenuse would get cancelled, and we get length of opposite side divided by length of adjacent side. So which is nothing but, basically the ratio we have is tan A. So finally what we can write here is, you have to remember this, tan A is going to be sin A divided by cos A. And we know that tan A is opposite of cot A, the reciprocal of cot A. So cot A we can write it as cos A by sin A. These ratios are very useful. Tan A is sin A by cos A, and cot A is nothing but cos A by sin A. We'll see one example problem here to understand the ratio of tan A. So example number 2 for this class we have. So we take the right angle triangle like this, and we have angle A here, and this is B we take, and this is C, and the length of opposite side to angle A is BC, and the length of adjacent side to angle A, that is AB, is 4K. This is given. And now above we have seen tan A is the ratio of opposite side to the angle A, that is 3K, divided by adjacent side to angle A, that is 4K. And here we can cancel the constant K from numerator and denominator, and we get it as 3 by 4. So this is going to be, tan A is 3 by 4. Suppose if we find the values of sin A and cos A and take the ratio, we are going to get the same answer here. Now to find the values of sin A cos A ratios, we need to have the length of AC. Okay, to find the length of AC, we are going to use a formula or a theorem here, which is called as Pythagoras theorem. Okay, we are going to use a Pythagoras theorem here. Pythagoras theorem, which is used to find the length of the hypotenuse. What this Pythagoras theorem states, the square of the hypotenuse is equal to sum of the squares of opposite side and adjacent side. Sum of the squares of opposite side and adjacent side. That is, AC is the hypotenuse, so AC square is equal to BC square plus AB square. BC square plus AB square. This is what the Pythagoras theorem states. Now we know what is AB, that is 4K, and we know what is BC, that is 3K. So we have here 4K whole square and 3K whole square. So we know that 4 square is 16, K square, 3 square is 9, K square. So 16 plus 9, we have 25 K square. So this is nothing but AC square. So if you take the square root on both sides, so we get AC square root of AC square, 25K square, square root. The square and the square root are going to get cancelled from LHS in both sides. And here what we have written 25, that we can write it as 5 square. So this square and the square root will get cancelled. Or another step we want, you can write like this, 5K whole square. Now this square and square root will get cancelled. What we get is 5K. So hypotenuse AC is going to be 5K. This is the length of the hypotenuse, which we have written HYP. The spelling we can have HYPOTENUSE, hypotenuse. That is length of the hypotenuse AC we got using the Pythagoras theorem. That is going to be 5K. Now we can take the ratio of opposite by hypotenuse. So what we get, I give some 2 seconds, you can just, what we get, I will just write the right hand side where I am writing opposite side, length of opposite side to angle A divided by length of hypotenuse. So what it gives, the ratio what I have to write on the left hand side, I think you guessed already, it is going to be sin A. Okay, so length of the opposite side here we have seen already, that is BC, and hypotenuse, that is BC equal to 3K, and AC is going to be 5K. Okay, so here we got 3K divided by 5K. So both the K will get cancelled and we get 3 by 5 here. So this is going to be sin A. Now similarly we can find cos A, cosine A. I'll give 1 or 2 seconds, you can tell what is RHS. In the denominator it is going to be length of hypotenuse. What it is in the numerator, can anybody tell? It is length of adjacent side, length of adjacent side to angle A. So to angle A, adjacent side is nothing but we have 4K. To angle A, adjacent side is 4K, and divided by length of the hypotenuse, that is 5K. So this we got it as 4 by 5. KK will get cancelled. Now if you take the ratio of sin A by cos A, we take the ratio of sin A by cos A, what we get here, sin A is 3 by 5, cos A is 4 by 5. We know that 3 by 5, 5 comes in the denominator. In the denominator 4 by 5, we can reciprocal when it goes into numerator, we get 5 by 4. So this 5 numerator, denominator 5 will get cancelled, we get it as 3 by 4, which is nothing but we already done it as tan A. So we can finally write it as, already we have written that sin A by cos A is nothing but tan A. Okay, so once we know what is sin A, we can easily calculate what is cosecant A. Okay, I am writing here with the red color. Cosecant A is nothing but reciprocal of sin A. If you take the constant here, that is 3 by 5 we got for sin A. Cosecant A, it is going to be 5 by 3. That is length of hypotenuse divided by length of opposite side. 5 by 3 is going to be cosecant. Now similarly cos A we have, if you want to have secant A, that is reciprocal of cos, we get it as 5 by 4. Length of hypotenuse divided by which side length? For secant A, it is length of the adjacent side. Okay, this is for today's class. Okay, please subscribe and share this video. Thank you very much. Friends, this is lecture number 3 for trigonometry, which we have started. Okay, in today's class we are going to see about relations between trigonometric ratios, and then one example problem we'll try to solve. Okay, now first we'll see the relation between trigonometric ratios. We have already seen in the previous class what are the trigonometric ratios. Now we'll see the relation between these trigonometric ratios. Okay, we have sin theta, cos theta, tan theta we have seen, and reciprocal of sin theta is 1 by cosecant theta. Okay, and we know that sin theta is nothing but length of opposite side divided by length of hypotenuse, and cosecant theta is reciprocal of this, that is length of hypotenuse divided by the length of opposite side in a right triangle. Okay, this is angle theta ABC. Okay, AC is the hypotenuse, the length of the hypotenuse L. Opposite to angle theta is BC. So length of the BC you can take it as some K, and adjacent side length you can take it as M. Okay, now if you multiply these two, that is sin theta into cosecant theta, we get it as, because sin theta, cosecant theta is 1 by sin theta. So this sin theta in the denominator and the numerator will get cancelled, we get it as 1. So this is one of the relation which gives sin theta into cosecant theta is equal to 1. One relation we have, that is sin theta into cosecant theta equal to 1. Similarly we have another relation, that is cos theta is 1 by secant theta, and we know the definition of cosine theta or cos theta, that is length of adjacent side divided by the hypotenuse, and secant theta is reciprocal of this cos theta, that is length of hypotenuse divided by length of the adjacent side. So if you multiply these two, that is cos theta into secant theta, if you multiply, so we have adjacent side length divided by hypotenuse length into hypotenuse length divided by adjacent length. So here this hypotenuse from numerator denominator will get cancelled, and the adjacent length and the denominator adjacent length will get cancelled, we get it as 1. So the cos theta into secant theta, we get it is equal to 1. This is equation, the relation, and second relation we can have. Now another relation we can have is between tan theta and cot theta. We know that cot theta is nothing but reciprocal of tan theta. tan theta into cot theta is 1 by tan theta. So these two will get cancelled and we get it as 1. So this gives the relation between cot and tan. When we multiply cot into tan, we get it as 1. Right. These are the three relations which we can have between the trigonometric ratios. Now we'll see one example problem. One example problem we have seen already in the previous lecture. Another example problem we are going to solve now. That is, if they give the relation between sine and sine of an angle. So we get here the problem, it is sine of an angle, it is given. Sorry for the disturbance. Example problem here we have, they have given sine A, small a it can be, or capital A, or it can be theta, anything, it is an angle. Sine A it is given, we know the sine is nothing but opposite side length divided by the hypotenuse. The given is sine A and they are asking to find, given sine A and they are asking to find other trigonometric ratios. Other trigonometric ratios they are asking with respect to angle A. Okay, find other trigonometric ratios of angle A. So we can take it as small a, or you can take it as capital A, or it can be theta, it is same. So they have given, what is given here, first you write, given is sine A is 3 by 6. So from sine definition we have opposite side length divided by hypotenuse length. So if you draw a triangle here by taking angle A here, this is ABC, this you can take it as angle A or theta we can take. Opposite to angle A we have is BC, hypotenuse here is AC. Okay, so the length of the BC here is 3, it can be 3 centimeters, you can write it as 3 centimeters, and length of the hypotenuse we have it as 6 centimeters. And to find other trigonometric ratios like cos A, we want to find, we need to have the length of the adjacent side divided by hypotenuse, length of the hypotenuse. So we need to find here adjacent to the angle theta, the angle A is nothing but AB. AB is adjacent to angle theta. So we have to find the angle, we have to find the AB length. For that we use the Pythagoras theorem. Pythagoras theorem is used. Using Pythagoras theorem, we can find the adjacent side length. So we know that hypotenuse square is equal to opposite side square plus adjacent side square. That is length. All these AC, AB, BC are nothing but lengths. And hypotenuse it is given 6 square. Okay, and opposite side it is AB, it is given, opposite side is BC, BC length it is given. Okay, and we need to find AB square. BC it is given 3 square. Okay, so 6 square it is 36, AB square, and 3 square it is nothing but 9. Now we bring this 9 on the left hand side, we get it as 36 minus 9 is equal to AB square. We know 36 minus 9 it is nothing but, how much we get? 36 minus 9 it is 27. So we get it as AB square is equal to 27. Okay, so we get here AB is equal to root 27. Root 27. So this is the adjacent side length. Okay, 36 minus 9 we get it as 27. Right. Now we want to find the cos theta. Cos theta is nothing but length of the adjacent side AB divided by length of the hypotenuse, that is AC. So it is nothing but root 27 divided by 6. Here we can have, even we can simplify this root 27 as root 27, we can write it as 9 into 3 divided by 6. So we can take it as root 9 into root 3 divided by 6. We know that root 9 is nothing but 3 into root 3 divided by 2 into 3. 3 into 2, it is nothing but 6. So numerator 3 and denominator 3 will get cancelled, and we get it as root 3 by 2. So this is nothing but the ratio of adjacent side length divided by hypotenuse, root 3 by 2, right? Similarly, we want to find what is tan theta. Tan theta is nothing but opposite side length divided by adjacent side length. Opposite side length is nothing but, which already given, it is 3 centimeters, and divided by adjacent side length, it is root 3 by 2. You can write it as centimeters here, root 3 by 2 centimeters. Overall this ratio, this centimeters will get cancelled. So this 2 goes into the numerator, we get it as 6 by root 3. And we should not keep any time root in the denominator. So we do the rationalizing here. 6 root 3 divided by root 3 into root 3 square. So this square root will get cancelled. We get 6 root 3 divided by 3, and here we get 3 2s are 6, we get 2 root 3. This is going to be tan theta. Similarly, if you want cot theta is nothing but reciprocal of the tan, that is 1 by 2 root 3. And if you want to find secant theta, how are you going to find secant theta? Secant theta I am writing here. Secant theta is nothing but reciprocal of cos, that is 2 by root 3. And if you want to find cosecant theta is nothing but reciprocal of the given sine, that is cosecant A. Cosecant A here we have, that is opposite of sine, that is 6 by 3, that is going to be 2. So that is cosecant A. So here cos theta I have written, it is cos A, and secant A, theta A you can take tan A. Okay, so this is cot A. Theta can take is, that is basically when we take a right angle triangle, here we can take it as theta. This is A, B, C coordinates. You can write it as angle BAC is nothing but the angle of A, that you can write even as theta also. Okay. Thank you for much watching. Please share and subscribe. Thank you. Students, this is, we have started a lecture series. This is lecture number 4 in the trigonometric of SSC mathematics. In this lecture 4, we are going to solve one example problem and one from the exercise 11.1 in the trigonometric chapter. First we will solve the example problem. Example we are going to solve. Okay, if I will write first the problem what they have asked. They have given, consider a triangle PQR, right angled at R, in which they have given the lengths PQ is equal to 29 units. They have given units are centimeters, millimeters, you can take, and QR it is given 21 units, it can be centimeters, and they have given that angle PQR is equal to theta. Then they are asking, then find the values, of, they've asked to here cos square theta plus sin square theta. Another problem of this question is cos square theta minus sin square theta. So we get a special case in this. When we solve it, then you can understand. Okay, so we have to find cos theta and sin theta, and what they have given the problem, the right angle is at angle R, that is 90 degrees, and they have given the PQ and QR lengths. And first we'll draw the right angle triangle, and they have mentioned the problem that the right angle is at R 90 degrees, and we can take now PQR. Now PQ is going to be the hypotenuse. They have given it as 29 units. You can take units or you can just write 29 also, because when we go for ratios the units will get cancelled. And they have given QR also, that is 21 units. QR is 21 units it is given. And they have given angle PQR. PQR is theta. This is angle theta which they have mentioned. This you can take, here they have not asked, it can be theta 1, but they didn't ask according for this angle. What they have asked is angle theta is at angle Q. I'll write here angle PQR, they are saying to consider it as theta. Okay, the center alphabet of this PQR is the angle which they have mentioned, that is theta, you have to take. Now we have to find cos theta and sin theta. To evaluate this, cos square theta plus sin square theta and cos square theta minus sin square theta. Okay, so we know that sin theta is the ratio of opposite side length divided by the length of the hypotenuse. Opposite to theta here is nothing but PR. So we have to find PR, which is not given. So that is length of PR is L divided by the hypotenuse length, that is 29 units. L is also you can consider as units. So we can L units divided by 29 units. Units will get cancelled. It can be centimeters, it can be millimeters, it will get cancelled. So to calculate sin theta, we need to have the length L, that is length of PR, we have to calculate. So how to calculate the length of PR? Can anybody guess? We have already seen the previous lecture that we have to use a theorem called, what it is? Pythagoras theorem we have to use. Pythagoras theorem is used here to find the length of PR. So we are going to write using Pythagoras theorem, which states that again PQ square, that is length square of the length of the hypotenuse, is equal to square of the length of adjacent side plus square of the length of opposite side. So here opposite to theta is PR, so and the adjacent side here is QR. So the lengths, PQ is length of the hypotenuse, PR is the length of the opposite side to the angle theta, QR is the length of the adjacent side to the angle theta. Right. So what they have given, PQ is given 29 square. You leave about the units, and we have PR square, it is given, we have taken it as L square, and QR it is 21 square. Okay, now what we have to find is L square, we need to find 29 square, it is nothing but 841. Okay, 29 square is 841 is equal to L square plus 21 square is 441. Now same way as we have done in lecture 3 earlier, we're going to bring this 441 on the left hand side. So we get 841 minus 441, that is equal to L square. Now what is L square is equal to 841 minus 441, it is equal to 400. From this we get L is equal to root 400, we have root 400, it is nothing but 20 units. You can write it as 20 units. Here we get, right. So we got the length of the opposite side to the angle theta. Now what we have to find is sin theta and cos theta, and we already have the hypotenuse length, that is 29, and we have the definition of sin theta. Length of the opposite side to angle theta is 20 units divided by the length of the hypotenuse, that is 29 units. Numerator denominator will get cancelled. So this is sin theta, and we know that cos theta is nothing but, in the denominator you remember always for sin theta and cos theta denominator is same, that is hypotenuse, and numerator of cos theta is nothing but adjacent to angle theta. Here we have, it is nothing but QR. QR is the adjacent side to the angle theta, that is 21. So here cos theta is nothing but 21 by 29. And they ask the first question here is cos square theta plus sin square theta, they are asking to find. So what we do here, 20 by 29 square plus 21 divided by 29 square. This is what we get, and we can take the LCM here. LCM we get it as 841, which is nothing but 29 square. So we get LCM is 29 square, because in the both the terms we have denominator is 29 square. Now for the first term we have in the denominator is 29 square, 29 square, 29 square will get cancelled, and we get it as 1 into 20 square. Same way for the second term also, 29 square in the denominator of this, and this will get cancelled, and we get 1 into 21 square. So we know that 20 square is nothing but 400 plus 21 square is 441 divided by 29 square is nothing but 841. So numerator is 841, 400 plus 441 divided by 841, both will get cancelled, and we get the ratio as 1. So what here we can conclude is, always for any angle theta, sin square theta plus cos square theta is going to be 1. This is very important identity which can be used in solving the problems. Sin square theta plus cos square theta is equal to 1. The second question asked in the problem is, they are asking to find what is cos square theta minus sin square theta. We know the ratios already, you need to just substitute and simplify the things. Cos theta we have already 21 by 29 square minus sin theta is 20 by 29 square. As usual, it is LCM is how much? 29 square, and here we get 21 square minus 20 square. Okay, so 21 square is nothing but 441, 20 square is 400 divided by 29 square is 841. So we get it as 441 minus 400, that is 41 by 841. So this is the answer we get for cos square theta minus sin square theta, right. We'll solve another problem, that is from exercise 11.1. We'll solve problem number 1 in this, that is they have given a right angle triangle ABC. ABC is a right angle triangle, and they have given the lengths of all the sides, and they are asking to find the sin A, cos A, tan A. Okay, they have given all the 4 all the three side lengths. Okay, so you can take it as A, B, C. Okay, they have mentioned it as a right angle triangle, and they have given the diagram here. The right angle is at angle B, 90 degrees, and they have given all the lengths. AC it is given 17 centimeters, and here BC it is given 15 centimeters, and AB it is given as 8 centimeters. This is given. Okay, these are given lengths. What they are asking simply is to find sine A. Sine A is what? We take the angle here. This is sine A. Sine A is defined as length of the opposite side divided by hypotenuse, that is 15 centimeters divided by 17 centimeters. Centimeters will get cancelled and we get it as 15 by 17. And we can calculate cos A. Cos A is what? Can anybody tell now? Cos A. Cos A is length of the adjacent side, that is AB, and divided by the hypotenuse. Okay, length of the adjacent side length is nothing but AB, that is AB divided by AC, that is cos A. AB is 8 centimeters and AC is 17. Always remember, length of the hypotenuse is going to be longer, it is going to be longer than other two sides. And if you want to find tan A, you can take the ratio of sin A divided by cos A, or you can take it as opposite by adjacent side lengths. Opposite side to A is 15, divided by adjacent side it is 8, 15 by 8. Okay, here we can have another is with respect to angle C. Suppose if they ask, by giving these all values, if they ask what is sin C, then what are the values? Sin C. Yes, anybody? What is sin C? It is going to be sin C, it is opposite side to sin C is AB, adjacent side to angle C, it is nothing but BC. Okay, so sin C is nothing but opposite side length divided by the hypotenuse, so that is 8 centimeters by 17. And cos C, if you want, for finding cos C, you have to find the adjacent side length, that is nothing but BC for angle C, that is 15, and divided by the length of the hypotenuse, that is going to be 17. Now if you take the ratio of this, tan C we know, you can directly calculate from the diagram, or you can take the ratio of sin C by cos C. Sin C is 8 by 17 divided by 15 by 17. Here we can cancel this 17 in both numerator and denominator. We get it as 8 by 15. This is tan C. Cot C is nothing but 15 by 8. Okay, and I am telling here cosecant C is nothing but 17 by 8. Okay, similarly secant C is nothing but 17 by 15. If you directly look at the diagram and want to find what is tan C, that is opposite side to angle C divided by the adjacent, that is 8 by 15. That is what we got here, 8 by 15. So from the diagram also we can calculate. Thank you for watching. Please subscribe and share. Thank you very much.